Hello students. Today we are going to study about the impulse and laws of conservation of momentum. Let us try to understand about the impulse. Impulse is nothing but J, and J is equals to, we can write F into T, that is product of force and time. We will consider a simple example. When a ball hits a wall and bounces back, the force on the ball by the wall acts for a very short of time, and when the two are in contact, at that time the force is large, and this force is enough to reverse the momentum on the ball. So the impulse here we have taken, it is a product of force and time, and here we can write the impulse is nothing but change in momentum, and this can be measurable quantity. So let us try to understand in detail about the impulse. So impulse is force into time, and that is nothing but change in momentum. So here for impulse you can write the formula J is equals to F into T, product of force and time. So a large force F, large force acting for a short time to produce change in momentum, and this type of force we are knowing it is impulsive force. Now let us try to understand this impulse with the help of example. Here we are taking the example of a high jumping or long jumping athlete is provided either a cushion or heap of sand on the ground to fall upon. So what is the reason behind it? Here what happened, the cushion or sand, it helps to increase the time in which the momentum comes to zero. But here if we will see about decrease the rate of change of momentum, at that time there is a decrease of rate of change of momentum. Rate of change of momentum, it is what, dp upon dt, and hence the force, it is also decreases. So the athlete does not get hurt because of that. So a high jumping or long jumping athlete is provided either a cushion or a heap of sand on the ground to fall upon. So you have to know here what happened, increase the time in which the momentum comes to zero and decrease the rate of change of momentum, and hence the force. So because of that the athlete does not get hurt. Now let us try to understand Newton's third law of motion. You already know the statement, for every action there is equal and opposite reaction. So here the two words are important, equal and opposite. You know that here these are always coming in pairs, action and reaction. So the pair of forces acting the two interacting object, and if you will see the size of forces on a first object equal to the size of forces on second object, and if you will see about its direction, it is opposite, and they always occur in pairs, action reaction. And if you will see about formula, that is FAB is equals to minus of FBA, according to a statement, for every action there is a equal and opposite reaction. Now let us try to understand some characteristics of it. The first is action and reaction are just forces. Next, the forces always occur in pairs, and if you will see about the action and reaction, they do not act on a same body. Now we will discuss about the acceleration. Though action and reaction forces are equal in magnitude, but they do not produce the equal acceleration. Here they are not producing the equal acceleration in the two bodies of a different masses on which they act. Here you have to know the forces are equal in magnitude, but they do not produce equal acceleration in two bodies of a different masses. So we will discuss example of it. We have taken the example of ball. If we'll throw a ball on a wall, it is what, action. Observe it, and it comes back, it is reaction. You will see the arrow, it is in opposite direction. So here for every action there is a equal and opposite reaction. Now let us try to understand law of conservation of momentum. You already know the statement, the total momentum of an isolated system of interacting particle is conserved. So how it is, that we will discuss with the help of vector treatment. Now let us try to understand the example of ball. Here we have to consider the example of ball. Observe it carefully. What happened in first case, these two balls we have taken, after that they collide on each other, and after that they have separated again. So here we have to discuss the three cases: before collision, during collision, and after collision. Here we have taken A and B. These are the two balls. The masses of these balls are MA and MB respectively. The velocities are VA and VB respectively. Its initial momentum is a PA and PB respectively, and we have to take its a final momentum, that is PA dash and PB dash. Now let us try to understand the figures. You will observe the first figure. In second figure, what happened? They collide on each other, and after that they get separated. So here we can use the Newton's second law of motion. As you know already, the statement of it, F is directly proportional to dp by dt. So we will use this, and with the help of this we will write the equation for FAB and FBA. So here F is directly proportional to dp by dt. We can write F into delta t is equals to delta p. So how can we write for FAB? It is nothing but FAB into delta t is equals to PA dash minus PA. PA dash is what? Final momentum, and PA is initial momentum. We can write for FBA. So FBA into delta t is equals to PB dash minus PB. Okay, final momentum of a B minus initial momentum of a B. So we have written these equations for A and B like that. Now we can use the Newton's third law of motion, that is, for every action there is an equal and opposite reaction. Observe it. We can take F AB is equals to minus of FBA. We have already studied this formula. Now we can write the equation like that also. FAB into delta T is equals to minus of FBA into delta T. Delta T may be cancel, and we will get the same. FAB is equals to minus of FBA. So here you already know we have written the equation for FAB delta T. We will put that equation, and we have written already for FBA into delta T. We will put that equation also. So we can write this is PA dash minus PA, and minus sign as it is in bracket we have written PB dash minus PB. So we can change a sign, and we will get PA dash plus PB dash is equals to PA plus PB, and you know that PA dash plus PB dash, it is what? Final momentum of an isolated system, total final momentum of an isolated system, and PA plus PB, it is what? Initial momentum, total initial momentum of an isolated system. So we can say that the total final momentum of an isolated system is equals to total initial momentum. So with the help of this we can say that the total momentum of an isolated system remains conserved, remains constant. So this is the vector treatment of law of conservation of momentum, and in that we have used the Newton's second law and Newton's third law, and with the help of this we have proved that the total final momentum of an isolated system is equals to total initial momentum of an isolated system, and the total momentum of an isolated system remains conserved. So next time we will discuss about the equilibrium. Thank you.